Good afternoon, dear colleagues. Good to see you. How are you feeling?
Fine.
Hi, hi. Everyone ready to continue?
Yes, yes. Да.
Okay.
Okay.
So hello.
Okay. Well, excellent.
Александр Анатольевич, я вот прям скажу. I think we should wait for the rest of us, yes? Because I think it's not so many people as we wanted to see. There are only 17 of you. I guess it should be like a little bit more, okay? Just a minute and then we'll start.
Today, participants of your event will be able to get acquainted with the competition task and software and see how to complete the task. You are ready? Let's go. Alexandrovna.
Okay, so we should start. And first of all, I would like to, present you a small agenda for our today event. So first of all, I would like to hear a few words from the participants about themselves. So please tell us your name, your surname, the country you are from, and why are you interested in space systems engineering. Then we'll discuss technical description and test project. And then we'll just build a workshop on the modules, which you will perform tomorrow, on Friday, Saturday, and Sunday. That's it. So, who would like to be the first to introduce himself or herself? I guess, Костя, не хотите представиться? Скажите, пожалуйста, о себе несколько слов.
Hello, my name is Alexander Konstantin Maximovich. I'm champion of Russia in our competition.
Sorry, we're just sitting here all together with our laptop.
I come to competition from school. I like space.
From my childhood.
From my childhood, and now I happy because I did what I like, and it's cool, I think.
И все, можете выключать звук, спасибо.
Nice, Костя.
Yes, thank you so much. Алексей? Нет? My name, скажите, как вас зовут, сколько вам лет?
Hi, my name is Alexey Alexeyevich Lopatin. I'm championship of Russia in our competition. Я не знаю, что сказать больше. I love space. Можно говорить на русском?
No. Okay, so thank you so much. So would like to be the next one. Okay, are there any other participants here?
Very warriors.
Shall I be the next one?
Hello, participants.
Yes, shall I say now?
Can people see me?
Okay.
Okay. My name is Graham Buckley, and I'm from Ireland, and I've been interested in space kind of recently in the last 2 years, mostly when it seemed plausible that we might be mining asteroids. Philae, the ESA mission, Philae, was pretty interesting to me, where they landed on a moving asteroid coming around the sun, and that's the main reason I got into it. So that's my story.
Okay, so very nice. Thank you. What about your team?
Thank you.
Yep.
Hi, actually, here. I'm Hannah.
Hi.
So I'm similar background. So I did my master's in space science, and I'm also on with the team for Ireland. I currently work in the space industry here, and I got interested in space by building Ireland's first radio telescope, and I was more fascinated with the instrument, and that made me interested in wanting to go into the space industry.
У них два микрофона. Okay, thank you, Hannah. So who would like to be the next one?
Yes.
Да, да.
Да. Shall I say?
Yes.
Yes. My name is Atharva Barbude. I am from India, and I am very much interested in space science from my childhood only. And now I am here in Samara University, Russia. Yes, I will be just entering my first course. And just from childhood only, I'm very much interested. When I got fascinated from one time, I was there in Russian Center of Science and Culture when I seen the Soyuz capsule. Before 2 years, I seen the animation of that in Mumbai, India. It was very interesting part. From there only, I met some of the colleagues of the Samara University who had just came there to give their introduction and all. So that's why just I'm interested to pursue my degree here in Russia.
Mm-hmm.
Thank you.
That's very nice. Thank you. Okay, so for those who cannot, who is not able to turn his or her microphone, it's okay. We're just, like getting acquainted, and we'll show you some workshops and tell you about the modules. So, Lorenzo, do you want to introduce yourself?
Hello, everyone. My name is Lorenzo Mantovani. I'm from Brazil, and I am an aerospace engineering. Currently, I'm in my a master's student in space systems at the Aeronautics Institute of Technology. And well, have always been passionate about space systems, so here I am.
Okay, so nice. We have many of you who have some, like experience or degrees in fields related to space. That's very great, interesting.
Can I speak? Good afternoon, everyone. My name is Arthur Gustavus Longo. I'm from Brazil, and I'm Lorenzo Mantovani colleague. So I am an aerospace undergraduate student, currently at my last semester, and soon I will be in aerospace engineering. And since my childhood, I think I am interested in a space system and things like that. I think it's this.
Great, another
Thank you.
space engineer. Thank you so much. Is there anyone else who would like to introduce himself or herself? Dun, 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 dun. Okay, so I guess it's it's all for now. So we'll just move on because we don't have much time, but we have very many things to do today. So first of all, I would like to mention and to say a few words about the rules for the camp. as far as you know, you have the documents, yes, about the camp, but actually there are almost no rules. So you don't have a age limit, you will not have any time limit, except for like time which is given for our conferences. Yes, and the most I should say pleasant thing is that after our camp, first of all, unfortunately, there will be no winners because it is a training, but everyone will get certificates. So experts and participants will get some certificates that they took part in the camp. And for those who just cope with the task more or less completely, so you will have, just a second, you will have a kind of, if you can see, a skill passport. Okay, a passport, a paper, which will show, just a second, I will show you how does it look like. So here will be your name and surname, the skill competition, space systems engineering, yes, and so modules and your scores on the modules. So
I
that's
know these boys.
yes. So this is the paper that
Konstantin. Sorry.
when you will just do your modules successfully. I'm sorry. Then we are going to the next thing. У меня видно демонстрацию экрана, да? Okay. So we are going to discuss technical description and the test project. So you also...
Нет картинки, Львов. А, вот, появилась. So you have a technical description on your Google Disk, yes? And it is a quite big document, so it is very long. But I'll just say in a few words, how does it look like, how to use the technical description. So first of all, it has an introduction, yes, to our skill competition. Then there are some ways to assess the modules that you have completed, the ways to assess the test project. But I should say that we have only objective assessment, and that means that your test project should be assessed by at least 3 experts, yes, and you can have either the highest score or the lowest score. That's it, nothing special. Then in the technical description, you have modules and time. Don't forget that this technical description is for real championships. So this one is from the World Championship in Kazan. So it contains full modules, yes, and full description. Now at the camp, we will not do all the modules. We'll do just a part of it. According to the original one, you have between 15 and 22 hours to complete the test project. Our skill competition requires only 21 hours, right? 21 hours to complete. So we work 8 hours during the first day, 8 hours during the second day, and 6 hours during the third day. That's it. Then we have some other information, but this information is mainly for experts. This information
is for you, but you don't need it now. It also contains like unit of occupational health and safety requirements, but actually it is written like you should follow the occupational health and safety requirements, which are defined for a special championship site and so on. Our health and safety requirements are connected with working with electrical devices, electrical hand tools, and maybe solders. That's it. Soldering irons, I'm sorry. During soldering, that's it. So nothing special. Then you will have here materials and equipment that you don't need it right now. And that's it. So today, a little bit later, I'll send you a short version of this test project, short version just for this championship. You will have the modules that you need during this championship. I'll just show you. So you will have module number 1 and its description, module number 2 and its description, modules 3 and 4, and module number 7, hardware in the loop spacecraft, I'm sorry, simulation. And you will also see 2 more modules that were not included in the camp schedule. So these are project cost estimation and corporate culture, and occupational health and safety observance and the workplace organization. If we speak about the last module, it should be observed during the whole competitions. It doesn't matter if it is a camp or a national championship, world championship, occupational health and safety should be observed all the time, okay? During all days and all modules. And so you will have to do project cost estimation. You can find the information about the costs in the internet, or you can take some data from a 6 modeler. You also, if you have just looked into Google Disk, you may just see that we have a report, yes? And in this report, you can see in the end, so the satellite cost calculation. So just 12 positions, and you can just find some information about the cost of the systems or logistics, or you can calculate it by yourself, or you can use data from a 6 modeler, so any way you like. So that's it. Okay, is it clear? No. Нормально, не все понимают.
Да, понял.
Okay. So now, we don't have, as I have already said, we don't have much time. So if you want, if you like, you can read the test project technical description by yourself, okay? But right now, I'm going to show and to maybe put your intention to read the modules that you are going to perform yourself, okay? Okay. So on Google Disk, you just may have seen that you have a folder with some 3D sensors, models of the sensors, model of satellite parts, and so on. Have you seen it?
No.
Александр, sorry, just a second. Александр Анатольевич, у вас, если рабочий стол, можете переключить, показать в папке, что там есть детальки, вот, ну или в 3D-модели открыть что-нибудь.
Five minutes, okay.
Вам надо на одном компьютере звук выключить.
Так, меня слышно?
Если, да, если пока не готовы, давайте я сейчас быстро покажу вообще, из чего у нас набор.
Быстренько, да, я подготовлюсь туда.
Да, давайте. Okay, so give me just 2 minutes. I'll show you why have we sent the models to you, because in original, yes, your module is to do a 3D model of a satellite, yes, using some parts of a satellite body and sensors. So you can get the parameters of these details. Here are. You can use your own ideas. Yes, you can use 3D models provided by us, by the organizers, or you can copy the sample or a template. Usually we give the participants the samples, yes, the original details. They just measure them and make 3D models, but we cannot give you, you know, like original details. So we send you 3D models. Все нормально меня слышно? Надо выключить демонстрацию экрана. Все отлично. Сейчас мы сделаем вот так. Здесь все видно. So, now we can see that we give our participants, yes, all of the parts. So the angles, yes, and other details. This one, another one. So all the details are given to the participants. They measure them with the help of a ruler or calipers, any other measuring instrument, and make real models, real size models of these details. We also have a kit with sensors. Oh. So you can see a flywheel, yes. Other sensors like sun sensor, high frequency receiver, I know, camera, speed angular sensor, and many other sensors. So power supply unit. So you don't have, you cannot just have these sensors right now. That's why you have, you know, like 3D models of these sensors. The task, yes, is to get a kind of, I have already shown you, but a kind of real satellite, yes, made of these details. So you just put it all together, put the sensors, connect them, and so on. But to build up this model, yes, to assemble this satellite, you have to make a 3D model first, because it is very important to arrange all these sensors correctly. So that's why you have to, you know, like perform the first module. Okay? Александр Анатольевич, готовы?
Это да или нет? Да что же вы улыбаетесь-то? Вас не слышно.
Так, меня слышно? Сейчас слышно меня?
Да.
Да, я сейчас покажу вам содержимое папки по ссылке, которую мы передавали. Так, сейчас, секундочку. Да. Если вы перейдете по ссылку, которую я отправил в Telegram, Александра, поможешь?
Sorry, I forgot to switch on my microphone. So I'll show you how to use the link I've sent you to Telegram.
Есть несколько папок. Одна из них это 3D-модели.
There are several folders. One of them is with 3D models.
И мы увидим восьмиугольный корпус. Он состоит из частей
Александр Анатольевич, мы ничего не
и
видим.
полной сборки. И также здесь лежат датчики в формате SolidWorks.
Александр Анатольевич.
Вы нас слышите?
Да.
Включите, пожалуйста, демонстрацию экрана.
Мы ничего не видим.
Ничего не видите? А у меня демонстрация экрана включена.
А мы не видим ничего.
Я понял. Так, отлично. У меня второй ноутбук не подключен, значит, получается. Да, ну тогда будем на этом. Ничего не поделаешь.
Тогда давайте следующего покажем.
Сейчас, да, я тогда перейдите по ссылке, да, я, в принципе, готов прокомментировать.
Покажите свою папочку с деталями есть?
Угу.
Да. Включите все демонстрацию экрана. Okay, so great. Now we have now we can see the folder with some of the sensors, not some, but with all of the sensors. Then we have a folder with the details. А есть еще папочка с детальками самими?
Можете перейти по ссылке, и там есть вся папка в Телеграме.
Нет. Okay, so just a second. Больше не могу. Okay, so what is the question? Chat. Александр Анатольевич, можно же не в Solid собирать 3D-модель?
Давайте я подключусь, я расскажу. Так, сейчас, секунду.
А что вы расскажете?
Что лежит по ссылочке? Перешли, нет?
Александр Анатольевич, вопрос.
Угу.
Пока не
Собирать можно в любой программе. Но самое главное, надо понимать, что 3D-модели, которые предоставлены, они лежат в файлах расширением Solid.
Okay,
да,
so...
Их или надо будет конвертировать, или у меня есть еще файлы расширения 3D Compass. Любые конвекторы есть, которые смогут их перекинуть из одного в другой формат.
So you may just use any solid state software for 3D modeling, but the models of the satellite body and so all the models are in SolidWorks extension. So you will have to convert it somehow into the software you will use. But you can, of course, use any software but all the modules we are providing you with are in for SolidWorks extension.
Можно добавить еще, что у нас работали в NX и какие, в принципе, если
Excuse me?
трансформировать файлы.
Hi. As you mentioned, any type of any model is fine, but it must be some kind of any specific format, mail for file format, specific file format.
Right now, you can use.
No, because if you want to print it, because you used to STP, it's kind of .pdf, something like. Is that any specific format you need it or something?
Да, промежуточно через step формат можно переформатировать в любой.
So you may use some converting software to save it in a format you will just use afterwards. That's it. But I'm not an expert in all solid state programs. So I think there must be some converting software.
Yeah, it's okay, fine, it's okay. It's never minded, because we can save us any kind of format in once you've done the modeling, so it's not a problem. Okay, thank you.
Okay, thank you. I'm just saying it that right now it doesn't matter, but during real competition, all participants will use one and the same software, but that is not just now.
Yeah, anyway, thank you. Okay, so now we'll just look at Alexei's screen demonstration. He will open the folders and show us the details. Подождите, не так быстро. Это одна из папок? Первая папка, да? So the first folder. So this is with the parts of an 8-sided body. So 8-sided body. You have assembly. Yes, so assembled body. And you have separate details. So откройте полную сборочку, покажете. Подъезд.
Да?
Okay, so the assembled, I'm sorry. Okay, the assembled bodies, satellite body, without any sensors. Крутите, покажите, что там средняя стеночка. So with aerodynamic suspension, with a part of aerodynamic suspension, and with the fastening elements. Покажите уголочки, пожалуйста. With fastening elements here. Ой, какая плохая сборка. Кто это сделал? Okay, so that's it. And you will have a folder. Спасибо, Лешенька. Folder with separate details. Давайте. So you may, like open. Okay. Можете еще покрупнее. You may open the folder and use the given details to make your own assembling. Okay. Or you may, like look at the detail and try to repeat it in your software, in SolidWorks or in any other. Okay. Okay. And там еще папочка есть с тачками. Okay, you have one more folder with sensors.
So as soon as you have assembled the satellite body, you have to use these sensor models, and you will have to join the sensors onto the satellite body. So that's it. Есть сборка с датчиками совсем вообще. Okay, so we'll just now try to show you the whole model of the satellite. А, вы только скрыть. А ты со своего можешь? Ну ладно, не надо. Okay, so now we can see the assembled 3D model of the satellite. It doesn't have any, Лешенька, перестаньте крутить, пожалуйста, any connectors or maybe any other additional like devices, but it has all sensors and sun cells. Покажите, пожалуйста, солнечные панели, что они там есть. Okay, yes. And so one of your tasks, okay, will be to count the mass, the center of mass, to count the mass characteristics of the satellite. Just a second, Лёш, можете чуть назад его отодвинуть, типа вид издалека? Выделите все, покажите центр масс. So we see анализировать массовые характеристики. Можете увеличить? Не, наверное, не получится. Okay, but here you can see, покажите, пожалуйста, массу. Наверх. Наверх, наверх еще. So you can see the mass. Yes, 3,369.57. And then the most interesting thing, we have the center of masses. Центр тяжести покажите. Интерференция. So yes, the center of masses. So you can see the. Выделите, пожалуйста, три оси. Центр тяжести и три оси. So you can see X, Y, and Z axis. Yes, and the parameters of the center of mass according to this axis. So as far as you can see, X is okay. I'm sorry. Yes, X is okay. Y is a little bit wrong, so it shouldn't be so small. And Z is minus 131, so that is okay. That is how it should be. Okay. Okay, so now we're going, another task for you will be to avoid interference. So the details, yes, must be joined together, but they must not, like cross each other. So if you have interference, then you will see a red line, or I don't know, maybe red lines and so on. And you can see also the interference in the results. Покажите, да, вот здесь вот. So here you also can see the interference in the model. Какая еще? А вон там маленькая совсем. Да, у Лёхи стоит нормально. Лёшенька, можете
Маховики можно посмотреть, там 4 винта обычно в интерференции.
Okay. So we also have, you know, like a flywheel sensor, and it will always have 4 interferences. So it is always wrong. So it's just about the program. It's not your fault. Можете отодвинуть назад и показать оси сами? Вот что X, Y, Z. Поверните его, как он должен быть, чтобы Z был вверх направлен.
Если ты мышкой на Z направишь, у тебя появится Z.
So that's stop, Лешенька, покажите оси. So you can see the axis, and it should be like that, you know, like нет. So the axis should be like this, okay? Pay your attention on the axis X, Y, and Z. So that is.
Надо сказать, что точка отсчета — это центр масс полусферы. Обязательно от полусферы надо идти дальше.
Okay, so when you start, you know, like drawing or modeling the satellite, you should start with this center. So that must be 0 on Z. Yes? And so according to 0, or on the 0 axis, you will have, you know, like minus numbers, like minus 100, minus 130, and so on, because the starting point is the aerodynamic suspension. That's it. Okay, so guys, if you have, because that was just a small presentation of module 1, yes? If you have any question, if you want us to show how to draw the details, or maybe how to do some other things, so you have the time right now. Okay, so just ask your questions or ask us to show you something.
If you don't have SolidWorks, something like, what kind of software would you recommend?
Just a second, Александр Анатольевич, если солида нет, что можно использовать еще? So you may use any kind of solid modeling software. Yes, if you have NX, for example, or Inventor, yes, any. But these details are saved in SolidWorks extension, so you will have to convert them by yourself. That's it.
If I'm submitting a model, do I also have to have it in a SolidWorks extension?
Can you repeat the question, please?
So if I draw something, maybe not in SolidWorks, and I save it as, for example, .step file or something like this, do I have to submit my model in a with a SolidWorks extension, or can I use something like a step and submit it as a step file? It must be submitted as SolidWorks.
Скажи, что степ открывает SolidWorks, но он открывает его с искажениями. И для оценки тогда необходимо будет правильно заполнить отчет, на котором будут видны виды спутника и расположение датчиков. Мы не сможем только измерить интерференцию, сопряжение и так далее. Можно вообще, да, если заполнить грамотно отчет, то можно будет принять работу так.
Okay, so just for now, you may use a step. Yes, the step will open SolidWorks files, but with, you know, like something will be wrong. You may do screenshots of the model in your software. Okay, but because you will have a 3D model, so you can just make screenshots. Yes. Put it into your report so that everyone can see your model from every side. That's it.
Okay.
I guess.
Sorry. Да, есть еще один вариант, то что у нас оценка экспертная будет на месте, поэтому эксперты могут оценить работу на месте. То есть не переводить из формата в формат, а протоколы заполнят эксперты компьютера и оценят работу на месте.
Александр Анатольевич, эксперты оценивают свои страны, мы не будем, да?
Правильно, правильно. Да, ну, конечно.
Я уточняю для вас. Okay. And one more thing is that right now we will not assess your model. Of course, if you like, we can look at it. Yes, but during the camp, your expert will assess your model. So if you use step, he will just open. If he has step, he can open your model in step. So no problem.
I got a question. Well, can you clarify about the distortion that you say, the interference? Can you clarify this point?
Okay, so interferences, Лешенька, можете эту модель выделить, показать? У вас здесь есть интерференция? Just a second. Нету? So look at this model, yes? All the... в маховике. So all the details are joined together, yes? But they fit perfectly, yes?
Yeah.
And if, for example, you draw or model a detail wrong, yes, if you just if you miscalculate something or anything else, so the details may be joined, yes, but they will, like interfere into each other.
Yeah, but in the drawing itself, there is no fastness. I mean,
yes,
it's like
yes. There are no fasteners, but sometimes, like participants make mistakes, and that cause interference. So the details. А можете какую-нибудь деталь сдвинуть, чтобы была интерференция? Крышку верхнюю прям воткните туда и все. Just a second. For example, yes, you make a mistake. Yes, like a very, very rude example. Соедините. See, this is the very, very bad interference. Okay.
Yeah.
Okay, so
it's clear.
That is clear. What we're talking about. So there should be no, like details like that.
It's proper of the solver that you are using. Yeah, it's clear.
Thank you. Лешенька, можете вот эту деталь удалить и еще раз показать маховик? So поближе. Just don't be afraid, because this sensor, the flywheel, will always have 4 interferences, 4 red points. So this is the bug of the SolidWorks or any other program you use. So that is not a mistake. It is just a bug of a program. Спасибо.
Okay. And it's only for that sensor, or
yes,
other
only
sensors?
for that sensor.
Okay.
Just a quick question about the connectors. Is there a standard distance between them? Because I don't think we don't model the actual connectors for everything. If there's a set distance for something, then.
So just look again. Look, I'm sorry, not again, but look at the satellite model. Лешенька, можете показать, как вот эту вот прямую выстроить и какого она будет, какой длины? So look, you just pick a point, yes, in a sensor. Pick it and draw a line till another sensor, yes? So you have, побольше сделайте расстояние, покажите расстояние, okay? So you have the distance, yes, between the centers, I'm sorry, and it is 122 millimeters, yes? But this line is straight. So you have to add maybe 6 or 7 centimeters, yes? And then you will have 120, oh, I'm sorry, maybe 130 millimeters. Yes, and that will be the length of your wires. Okay. So that is how the participants measure.
Скажи еще, пожалуйста, что можно использовать Electrical 3D, которая входит в состав блока настройки. Там есть построение сетей. У кого есть лицензионный солид, можно использовать эту настройку.
Мы это можем показать сейчас?
К сожалению, в колледже нет этой настройки, но если ребята занимаются профессионально, скажи, пожалуйста, об этом, да, и мы должны об этом знать.
Это в солиде прям, да?
Да.
Okay, so there is also some addition to SolidWorks. It is Electrical 3D, which can also measure all the wirings, yes, and
connect
other things, yes. But unfortunately, we don't have this program. If you have it, you may use it. But still, this is the simplest way to measure the distance between the sensors.
One question. In this first step, we should draw the wiring, or it's second stage?
Okay, so just a second. In your report and in the technical, I'm sorry, in the test project, you have a task to make and to fill in the documentation about the wires. Yes, you don't have to draw them, but you have to just measure the distance, because may I just switch my camera for a second, switch on my camera. Лешенька, выйдите тогда из своего, ладно?
But for that, we need the wiring diagram.
Yes.
So we can see where they go.
Of course, just in a minute we'll show it to you, but right now.
Okay.
Okay, so I would like to show
another thing. In the drawing, I don't see the solar panels.
There are no solar panels in a four-sided satellite. Unfortunately, we have it only on a 8-sided. So look, you have sensors, yes, and originally you have once more the kit, yes, and the kit, and you have like a big wiring. So the participants should, you know, like measure somehow the lengths of the wiring needed.
I can hear you.
Can you hear me now?
Yes, yes.
Okay,
now.
sorry. So they must somehow, like measure, yes, the wirings. For example, you see here
Yeah.
7, 310. 7 means the number
7
of the
wire.
wire, and 310 as its length. So they just measure in 3D model, like the distance. Then they cut here the wirings, mark them, and only after that they connect the sensors in a real model. That's why they need it. And right now I will just show you the demonstration of my screen. Wait a minute. So in the report, yes, there will be, look, number 4, the cable network report. Yes, the diagram of the satellite cable network between the sensors indicating number and length. So first of all, you will draw, it may be like this. For example, number 1, number 2, and you will just have like sensor number 1, sensor number 2, and how are they connected? Or you may
Okay, it's like a block diagram, right? It's
yes,
like a
yes.
block diagram architecture.
Yes. And then the table of cable length. So you will have to put, for example, number 1. Сейчас с чем соединим, ребят, нам первое, что с чем соединяется? Okay, so that will be cable number 1. The 2 sensors, it connects its length. Какой он обычно длины? Okay, so for example, like this, yes? And with tolerance, it will be maybe like this. That's it.
Okay, but we need electrical diagram sketch because we don't know which sensor to which sensor we should connect, or to what device it should be connected. So
I got it.
So you will give us this sketch or diagram of connection?
Александр Анатольевич, на спутнике же есть, что с чем соединяется, по последовательности датчики должны соединяться.
Давай я немножко расскажу, ты сейчас переведешь. Значит, общую цепь надо строить так, чтобы соблюдалось правило равноценной нагрузки, подключаемой к первому и ко второму разъему на системе энергопитания. Сможешь перевести? А я попробую дальше.
So the idea is that the whole block diagram should, coordinate the voltage so that it should be similar. On one, I'm sorry, just a second. So you have
you know, like 2 pins, yes? And the voltage should be more or less similar to each of the pins. That's it.
Два разъема между собой подключены параллельно.
So they should be connected in parallel.
То есть напряжение на первом разъеме соответствует напряжению на втором.
So the resistance here should be equal to the resistance here. So the resistance between the pins should be the same.
Два разъема сделали для того, чтобы кабельная сеть имела возможность обхватить спутник с двух сторон.
So all the sensors, almost all the sensors, have 2 pins, yes, so that the cable network could go around the satellite.
И последние датчики нельзя соединять между собой. Один разъем должен всегда оставаться свободный в каждой ветке.
Так непонятно будет, мы вышлем диаграмму.
Я думаю, что надо будет нарисовать просто ребятам показать.
So the last sensor in this circuit, yes, the last sensor in the circuit should have one free pin. Okay, so this pin shouldn't be used on the last sensor. So that's it. But if you need, we'll just send you the block diagram so that you can see how should the sensors be connected. Okay.
Okay, that will be great.
Okay, so this is about the 3D modeling, and just 1 minute for you to look to the report. So because it will just make life of the experts easier. So first of all, you will have to assemble satellite, yes, and make a print screen of general view of a satellite. Okay, so you may just do some print screens and put it here. Then general view of the satellite with arrows indicating the sensors. Yes, so you will have to make a print screen of the satellite from each side. Yes, and you should write how what are the sensors. For example, sun sensor 1 or angular speed sensor and so on. And so you just read what print screens are needed, do it, and insert it into the report. Then, as you have already seen, the satellite center of mass coordinate table. So you can just get this data from the software, yes, and put it like this. Здесь должен быть Z. Sorry, that's... И все. And you will win. Actually, okay, it's better to make a, like print screen of the table of center of masses, but you may just do it yourself. Then you, in your software, you also can see tensor of inertia, yes, and different axes, x, y, z, and so on. So you also put down some of the data here, and that's it. Then you will have to look into the satellite mass according to 3D model, yes, and put it here, like it may be in kilograms. So sorry, that will be like And the next step is the real mass of the satellite with cables, fasteners, and other devices. So you cannot like measure the cables, yes, fasteners, and so on. So you should add, for example, that word. You should add about maybe 1 kilo, and you'll have okay. So you just add 1 kilogram because it is like something close to the real mass of fasteners, cables, and so on. Then you will have to make a print screen of the assembled satellite. The assembled satellite. And so the cable network will send you the diagram of cable network, but you will have to measure the cables yourself. So that's it. Okay, so just think about the questions you may have, and I want to remind you that actually this module is done and assessed during the first day of the competitions. And the participants have 8 hours, yes, to perform the first 3 modules. А у кого там? 8 hours to perform the first 3 modules. Tomorrow we'll check this module from 2 till 4 p.m. according to Moscow time zone. So you will have time either today, okay, or tomorrow. We will not limit you with the time, okay? But please, just the time for this module should not exceed 8 hours, okay? So we think that 4 hours should be enough for this module. Okay, is it clear? А чё они молчат?
Okay.
Okay, so because tomorrow at 2 o'clock we'll start checking and we'll show your experts how to check the models, and then till that time your models should be ready. So that's it. Не знаю. Ну ладно.
I have a question.
Yes.
Just to be sure, we need to assemble the 8-sided model and not the
Yes.
4-sided model, right?
You need to assemble 8-sided model.
Okay, thanks. And another doubt, you mentioned the aerodynamic suspension system and satellite. What is it exactly?
Okay, so I just could figure out the aerodynamic suspension system, and the next part was missing. What was the second part?
No, I just asked, what is it?
Okay.
Oh, okay.
If you just give me 1 minute, I'll show you what for. So to check the balance of the satellite, we have to put it onto the aerodynamic suspension, yes, to check the center of masses. Just a second. Dima, Тебе надо, чтобы все отключились или кто? Да, сейчас. Я вообще сейчас остановлю, мне сейчас она не нужна. Just a second.
So we have, can you hear me? Okay. So we have this part of the satellite to put it onto the aerodynamic suspension here, so that it could, like turn any side, and so that we could check the center of masses. So this is just a part of the construction. Нет, Лёша, просто она у Димы там, за Димой. Все слышат этот треск? Я ничего не могу сделать это оборудование. А? Спасибо. Кто его еще включил?
Я не выключал.
Я выключила. Okay, so this is done just to put the satellite on the aerodynamic suspension. Okay, so that's it.
Give it to the phone. Telephone.
Что, больше не трещит?
Нет, все нормально. Нам надо камеру GoPro.
Ну, пока так. So if you're ready, we can just look into the next module, and it is, if you don't mind, satellite modeling simulation in SX Modeler software. So so now seconds. А вы запускать его будете? Или тут заполнен или нет? Okay, so this is how, just a second, Alyosha will show you how does this software look like. Yes, if you just afterwards give me some time, I'll show you the annex for SX Modeler. It has different data. So you can see... Не вылетел? Полностью? Ну, пока выключай тогда. So, in this annex to a SX Modeler, you have different data. For example, the start of modeling time, the end of modeling time. You have different cities like Kaluga, Zurich. You have the orbit parameters. You have the name of scenario. You have the name of the satellite. You have some mass characteristics and so on. And if you just put this data into this software, if you put everything correctly, you can, and the calculation for the satellite and see the stabilization of a satellite in 3D program. Вы сейчас по новой будете заполнять? Или нет? So now we can just, like look how we can see how does this software should be fulfilled. Though Alexei uses Russian version, помедленнее, пожалуйста, спасибо. Russian version, but in English the like the tabs are the same. It has the same names, so everything is just the same. So this is the name of scenario, the satellite options. And here is the name of the satellite. Here are the time, simulation start time, simulation stop time. Два раза start time написано. Приложение ужас. Почему одни и те же? Время просто 13:59 дней, все нормально. Тогда заполняйте спокойно, все пусть смотрят.
Мы можем еще пока заполнять, рассказать о том, что главная цель этой программы того, чтобы рассчитать энергобаланс на борту. И
Как его рассчитать?
Рассчитать с помощью графиков. Мы прогнозируем, вводим данные по энергопотреблению всех систем и датчиков. И потом смотрим на графиках, достаточно ли нам энергопотребления на борту. Либо проводим его коррекцию путем повышения площади панелей или коррекцию аккумуляторной батареи по емкости.
Спасибо, что делаете паузу между предложениями. So the most important thing about this software is that it helps to calculate the power supply system энергопитания на борту of the satellite. So it is just for the calculating of how much power is demanded to, like support the satellite in flight. You can correct or check somehow the power supply on board of the satellite, changing some of the numbers. Yes, so for example, you will have the power consumption of onboard computer or camera, transmitter, and other systems. But you can correct it a little bit so that the satellite power consumption should be optimal, should be the best. That's it.
Sorry, one question. The software and the diagram will be used in what stage of the competition of
Okay, so this
task is part of a task or
this software is the part of the test project, and during the camp you have to do this module on Friday. the participants have to do this module on Friday. So we are yes showing how to use this program, how it should look like, but it is not very you know, like difficult to figure out or to you know, like to learn to use this program, because you just copy the data, you may change it a little bit and see the result. That's it.
In the practice, how it's connected the program to the real satellite, or for example, in the competition, you have to send the data from the software to the satellite in a real competition.
In a real competition, it is just a program to count the consumption of a power supply units. So you have to, you know, like calculate how much energy or how much voltage is needed, for example, for a camera proper work, or some, I don't know, computer work. So they have just to calculate the power supply of all sensors and equipment that are installed into the satellite. Actually, this module is a little bit separate from all from the whole test project, yes, because we don't use this particular data anywhere else.
Либо еще можно добавить, что есть вторая часть программы SX Modeler, которая называется Orbit Control. В Orbit Control можно закладывать в режиме полетного задания или в ручном режиме отключения, включения различных систем. И как раз используется. Да, ты расскажи, я сейчас добавлю.
But together with SX Modeler, we use Orbit Control software. Yes, so another program, it is like called OBC. And this program helps the participants to calculate the number of shooting sessions and transmitting the shots from the onboard camera, from the satellite camera, into the centers that can just receive these photos. And also this program, this software, help to test the payload, I mean the camera. So together with the SX Modeler and OBC, only together, with the help of these programs, they can test one of satellite component.
Да, управляют спутником в режиме ручного полета или в режиме полетного задания. И можно контролировать энергобаланс на борту, и можно включать, отключать все системы на компьютере во избежание повышенного расхода энергии.
Хорошо, там еще был вопрос, знаете, какой, типа, почему, а вообще зачем этот SX-моделер, как мы его дальше в конкурсном задании используем со спутником?
Наша задача выполнить численное моделирование полета спутника относительно его центра массы.
Это не ответ.
Это ответ, это позволяет окунуться, скажем так, в космическую тематику ребятам, которые участвуют в этой компетенции.
Как это
они
используется
учатся,
в спутнике?
Да,
Ну,
они
в смысле,
учатся
в нашем.
рассчитывать энергобаланс на борту. Вот, наверное, так можно будет.
Ну, это я уже сказала. Ну, ладно.
Да, ну и у них есть общее представление о том, как спутники проходят через терминатор, видимую линию дня и ночи, ну и так далее.
So, Javier, this program also, you know, like just help the participants to understand how can they change the power consumption of the whole satellite just by changing power consumption of some units of the satellite. That's it.
Okay.
So it's
Да, можно еще сказать, что это реальная программа, которая была написана для управления спутником Чибис-М и Аврора. То есть с помощью этой программы управляли реально запущенными спутниками.
Да. Unfortunately, here during our camp and during our competition, we don't use this program with the software with our satellites, but this software was created specially to control a real satellite that was Chibis-M and Aurora. So these satellites are operational. Сейчас на орбите?
Нет, сошли в 2012 по 2014 2 года пролетал вместе.
So these two satellites were launched on 2012 and they finished their missions in 2014, sorry. And so the developers of this software used this particular program to operate these satellites. So it can be used, but not for our satellites.
И подобная программа использовалась для расчета энергобаланса на борту студенческих спутников Sirius-1 и Sirius-2, которые до сих пор летают на орбите.
Okay, so the same software is used to operate satellites that are in the orbit now. They are called CubeSat. They are made by students of МГУ же студенты делали, да?
Нет, это школьный CubeSat в Сириусе, в научном центре. Они так и называются Sirius-Sat-1, Sirius-Sat-2, которые были запущены с борта МКС 2 года назад, в августе месяце.
So these satellites, CubeSat-1 and CubeSat-2 were launched from the board of International Space Station, and these satellites were made by school children, but still it is in the orbit now. So now, please, guys, experts and participants, you can see 3 diagrams of power consumption on board of the satellite, and you can see 3 axes, the satellite and its 3 axes. Лешенька, сейчас вы что делаете? So now we are waiting for the end of the calculations. So when the calculations are finished, он стабилизируется или что? Зачем вы ждете тогда?
Когда вы рассчитаете, эти данные можно будет перенести в ОБЦ.
Хорошо.
Ну, я думаю, на этом можно закончить все. Просчитать мы пока можем пойти дальше, а итог потом покажем.
Okay, so while we are waiting the end calculations, so we'll just move on, and afterwards Alexey will show us the results of these calculations. And now I would like to move to modules number 3 and 4. So, Лешенька, можете выключить демонстрацию? So now our next module is sensor system and equipment programming and satellite independent tests. So as I have already mentioned, we won't perform independent tests, but we'll show them to you because you don't have sensors to test the codes. So the task here is just to make some general algorithms, not some, but a general algorithm, some detailed algorithms, and write and compile the codes to test all systems and sensors from the set of Orbicraft. So to write these codes, to see everything, you should use Spotnik's website. Костя, можете свой экран включить, пожалуйста, коды покажете, как компилируется, как пишется. So just a second now. Да, Найт, зайдите, пожалуйста, на Spotnik's, включите демонстрацию экрана. So here you can see Spotnik's website. You need here, okay, so какой-нибудь код, как его в Notepad, например, скопировать или отредактировать, скомпилировать. So you may just look here, you have the description of all the sensors, yes, and an example of code, of a programming code to check some of the sensors. So for example, magnetometer. So this one is a magnetometer, and you can just copy the code. You may copy the code. Не показывает. Вам нужен самый верхний экранчик. And insert or paste it into Notepad. So as soon as you have finished, you have to choose the programming language. Yes? Okay, so that is C. You may correct the code somehow, or you may write your own code. Then you have to compile it and to make a folder. Отлично. Ее надо в zip? Это в zip надо или просто в папку?
Папка. Папка должна быть обязательно на английском языке, без пробелов, без кириллицы.
So you have to create a folder in English and then insert your file. So if everything is correct, so you will see like starting zip OK and cleaning. So that means that the code is compiled. Да. If you have any mistakes, so during compilation, you will see the next thing. So you will see the path. Чего, Кость, скажите?
Видит, он хочет показать то, что при возникновении ошибки, в данном случае здесь нет у нас точки с запятой, возникает красная строка, которая указывает на строку ошибки и показывает, что чего не хватает в строке. В данном случае здесь нужно добавить точку запятой.
Okay, so you can, if you have any mistakes, so the program won't let you compile the code, and it will just show you the mistake, the line, and so on.
Да, и желтым выделяется то, что если вдруг не красно, а желтым выделяется другим цветом, то с этой ошибкой возможно работать дальше, и файл компилируется.
Okay, so if you have mistake that is highlighted with yellow color, that means that you can just work with this code further. So it is okay, quite okay, but it's better to just correct it. Да. Okay, so you have the simplest code. So check the computer. Okay, then you have angular speed sensor, check code. И шо? Я же не слышу. So here you have just turning on, turning off, and getting some of the notions, some of the numbers, values. So magnetometer is the same to angular speed sensor, is almost the same to the angular speed sensor. Я думаю, Кость, можно дальше уже не показывать, потому что коды, примеры есть, описание датчиков есть. Можете еще раз, пожалуйста, на сайт зайти? So, ну да, мы и так на английском, а они на английском ссылку кинули. So you can see, you may just look. Okay, so you can see the descriptions of all sensors and examples of all codes in Orbicraft website. So it's not very difficult. You may use these particular codes, or you may just write it yourself. For example, на каком еще языке можно писать? А еще на каком? Все. Окей, а здесь, наверное, питон не надо, да? Ладно, ничего не буду. Окей. So just use this website to look at the codes. Then we are going to show you the examples of the algorithms. Можете, Кость, включить, да. So here is the example of an algorithm. So you may just use a piece of paper, yes, and to write it with your hand. Or you may use, for example, Paint or any other software. Just you should make some print screens, okay? Or take pictures of these algorithms and put it into your report. That's it. For example, we have, Кость, покажите the beginning, начало. Да, вот так. Начало, the beginning. Then we have stabilization and orientation system. Then we have orientation. А куда вы стрелочку двигаете? Stabilization, we have magnet stabilization. Отлично. А другую покажите. Я же не вижу. Нет. Ну вот что у вас справа написано рядом с магнитным? Okay, so then you have stabilization by flywheels. Just a second.
Hello, come back.
Hi, Konstantin.
Hi.
So
The link for the web page that you show, it's in the chat or in the Telegram?
Леш, меня слышно? Все, а что вы молчите-то?
Потому что звук оттуда идет.
А почему все молчат?
Javier, repeat, please.
So you have one more time a general algorithm which had the beginning, then orientation and stabilization system, which is about orientation. It may be sun orientation or magnetometer orientation. So some sun orientation is about to switch on sun sensors number 1, 2, 3, and 4 on the flywheel. Then you will get values from the sensors. Then you have to calibrate the sensors. You have to calibrate the values. Then you can get the angle you need and to give or to transmit the values from the flywheel. And if the orientation is done, that means that it is the end. Yes. I'm sorry, no, it is not the end. If the orientation is done, then you have to
Подача сигнала на радио.
to transmit the signal.
Relay.
To relay. Then you have to get the values from sun sensors. Then you have to turn sun panels, sun cells panels to turn on the camera and to turn on the transmitter and then to turn off the transmitter, and that will be the end. Yes, if we have this condition is not complete, then you will again have to get the values from the sensors and so on. So that is the general algorithm, the example of the general algorithm. Так, Костя, тогда вы выключайте демонстрацию экрана. And I will just show you my screen, another example of algorithm. So because the algorithms may be very, very, very different. So it depends on how the participants just see the algorithm and so on. So another example as this one is again the general algorithm. Только все равно ничего не видно.
Я не очень хорошо вижу.
I know, but I cannot do anything. Just a second.
Можно вы прислать в Telegram?
Okay, maybe some of the codes. Just like this algorithms is from one of our students, so he just gave it to us.
Yes.
So just an example for.
Нужно сказать, что потом, следуя логике определения алгоритма, мы сможем проверить написание кода, стабилизация, ориентация.
Подождите, чуть-чуть, подождите, я же не закончила. Сейчас, секунду. So, for example, the algorithm for payload. So you have a payload to switch on the camera, to wait 1 second, to just transmit the photo, to turn off the camera, to turn on transmitter, to wait 1 second, and when flying above the zone of shooting, to transmit the picture, and then to turn on, or to turn off, I'm sorry, the transmitter. For example, another algorithm, it may be like this. To disclose the solar panels, to transmit signal low from Arduino, then to burn the string and to transmit high signal. So the algorithms may be, like very, very different. But the thing is, and the idea is that the algorithms should be clear and it should follow some logic. Yes, so it should be logical. Actually, it is no page for the algorithms. Yes, so there is a page for codes, but there are no algorithms there. Александр Анатольевич, на спутник же нет алгоритмов? Нет. So the idea is that one of the participants, okay, should imagine how does the system work. Yes, and according to his imagination, he draws the diagram, the algorithm of working, because it may be very, very different, but it should be logical. For example, to turn on, to turn off something, to turn on, to transmit, to receive, and that's it. Да, Александр Анатольевич, что? Александр Анатольевич, я вас перебила, вы что-то хотели сказать.
Нет, все, продолжаем дальше. Хорошо.
Okay, so during these modules, you will also have to put a picture or drawing or photo, yes, of different algorithms, and you should also print screen the written and compiled codes. So as soon as the code is compiled, so you should print screen it and insert into the report. That's it. That is all for the programming. I'm sorry, not for the programming, but for the part of the programming. Now we have another part of this module, module number 4. software developing and debugging. They go these two modules, module number 3 and module number 4. They come together, and they should be done in one day. Okay. So during this module is not very difficult. So the task here will be to, you know, like you have developed a general algorithm, you have just written and compiled some of the codes, and the general task for this module is to try to compile the codes for stabilization, orientation, and so on. So to compile all other codes that you can compile. Александр Анатольевич,
Да.
по модулю вот этому им же надо скомпилировать коды ориентации, стабилизации и так далее. Ну, все, которые смогут, да?
Да, компиляция происходит для всех программ работы системы и подсистем, а демонстрация будет только лишь стабилизации.
Ну, это мы еще, да, не дошли. Okay, so that's it. If you have any questions on this module, so please ask them now. So dear participants, experts, if you have any questions on programming, so please ask them.
One question. I have one question. The programming is under the codes of Arduino?
Not exactly. So they work with Arduino, but it is like a very, very small part of the code. Generally, they just write check-in codes for all the sensors that are described at Sputnik's website. And they also, if they are able, they can try or they can write codes for stabilization, orientation, or some other things. If, for example, your participants, yes, or you, or someone else, will try to write a code, yes, and nothing will just work, we will just show you some of our codes, how to write it, and how do they work. That's it.
Okay. The website of Sputnik, can you put a link in the chat or in the
Yes, I'll just
or
send
in Telegram? Okay.
Yes, sure.
Okay. Thanks.
Okay, so if you okay, so if you just will remember, well, just if some of the questions will came to your mind, you may write it into the chat and we'll try to answer it. Now, Лешенька, у вас закончено все? So now we are going to look again, we'll just go back to our 6 modeler and see the results of the calculation. Где? Okay, so 75% as the capable depth of the discharge. And if our battery capacity is 47 amperes an hour, and we'll just try to figure 75%, then we'll have 35.25 amperes hour per hour. Что это? Well, and we should look into the diagram with capacity, yes, and look that the values are not lower than 35.25. That means that the calculation is correct. Дим, подойди, пожалуйста. Ничего. Все? Угу. Откройте, пожалуйста, да. So here on the map you can see the shooting zones and transmitting zones. So the shooting zone is Zurich and the transmitting zone is Kaluga. You start the counting and you can see a small satellite flying around this zones. And now you should... Еще нет, да? Okay, so you stop it here, here. Да подождите, что же вы делаете? Вы будете что-нибудь комментировать или нет? А теперь уберите маленькое окошко чуть-чуть в сторону. So we should stop. Да подождите вы, боже мой, ну что же вы делаете? Вы издеваетесь надо мной? So you should stop the satellite in the shooting zone when it is in the light. Yes, so and that moment will be the time of your shooting. Покажите, где время взять. So here you have the time. Yes, so that will be the time of the shooting. Это время съемки, правильно? Сделаю вот так.
Леш, прокомментируй, пожалуйста, какие команды ты передал от payload и какие, в какое время, какие даты прохождения через контур зоны съемки.
Что вы говорите?
Да, сейчас что происходит? Команды, которые передались из SX моделлера, они передаются для управления в Orbit Control.
What is happening now? The commands from a SX modeler is transmitted or and received by Orbit Control, by OBC.
Управление камерой осуществляется в 3 режимах. Включен, выключен.
The camera is operating in 3 modes.
Включен, выключен и стендбай.
On, off, and standby.
И также работает передатчик в 3 режимах.
The transmitter is also operating in 3 modes, on, off, and standby.
И мы можем контролировать включение, выключение трансмиттера и камеры в определенное время, во время пролета его над зоной съемки, либо над зоной передачи.
We can control the camera and transmitter when the satellite is flying above a certain zone.
Либо в ручном управлении, или в полетном плане.
We can do it manually or with the help of flight plan.
И если сейчас нажать в вкладку питания, Леш, нажми, пожалуйста.
So if you
вот здесь.
just tap power consumption.
Правее. Вверх, вверх, вверх. Смотри, где ручное управление и полетный план. УБЦ. УБЦ, да. Вот мы увидим потребление системой напряжения.
We can see the power consumption of power supply system.
Ну все.
That's all.
На этой картинке видны координаты, зоны координат съемки и передачи.
In this picture, we can see.
Если задача перед спутником стоит съемка определенных координат, то мы можем включать-выключать передатчики трансивер при прохождении зон съемки и зон передачи сигнала.
We can switch off and on the transmitters when the satellite is flying above the zones of shooting and transmitting.
Да, ну, на этом, наверное, вся работа в SX-моделлере закончена.
That's all.
Так, что у нас осталось по таймингу?
So, звук. We should have finished until now, but as I have already said you on Monday, we'll just it will take us a little bit more time today. Okay, if no one minds, we'll continue. There are only 3 modules left. One of them is quite difficult, but the last 2 modules are very easy. So I guess that will finish in maybe 30 or 40 minutes. If you just cannot be present here for some time, where you just have to leave, you may leave. So you will just have all the info in Google Disk again. But if you just have an opportunity to stay with us, we'll show you the last 3 modules. And it is module number 7. It is hardware in the loop satellite simulation. So to complete this module, you have to download this the software. I don't even know how it is called because it is a new software. So, Александр Анатольевич или Костя, кто нам будет показывать?
Я думаю, Костя, покажи, пожалуйста, симулятор.
So Konstantin will demonstrate this program to us.
Так. Сейчас я прям с самого начала ее найду. Вот она, вот так выглядит.
Okay, so this is the program.
Запуск от администратора надо делать.
Okay, so you have to run the program from admin.
В этом поле мы меняем все наш код. Изначально он загружен, и он работает. Здесь можем поменять... да.
Okay, so here we can run our code.
Здесь мы можем менять значение коэффициента, шага и целевой скорости.
Okay, so we can change the values of different coefficients of time step and omega speed, I
Целевая
guess.
скорость. Целевая.
Okay, of goal speed.
Чуть правее можем менять характеристики самого спутника.
Here we can change the satellite characteristics. For example, we can change the angular speed, the mass of the satellite, inertia moments, and so on.
Слева сверху можем выбрать модель.
On the left top corner, you can select model file.
И снизу мы можем запускать и останавливать программу.
On the bottom of the page, we can start or stop the program.
Вот, она остановилась.
Okay, so it's stopped.
Так, также у нас есть консоль, в которой показано то, что мы выводим в коде. То есть можно увидеть в самом коде, написать что-то, и оно будет выведено в консоли.
Okay, so the code itself may be shown on the console. So you may just spread this window and look how your code is running.
Ага.
Стабилизация?
Да.
So this is the stabilization code running.
Все значения вводятся и в консоли, и в программе. В программе они вот слева показаны.
Okay, so in the program, on the left bottom, you can, under the picture, I mean, you can see the values, and these values are also shown in the console window.
Это все.
Во время жизни так спутники стабилизировались.
Угу. Собственно, проект программы все.
Okay, so in general, that's it about this program. Unfortunately, right now we... Выключите у себя звук, ладно? Спасибо. Unfortunately, right now we can just download the stabilization code onto this software, but later they should be developed, and we will be able to download and to run all the codes. So, for example, orientation, photo shooting, and so on. So that is it about this particular model. It is not very difficult. It is not difficult at all, I should say, but it is the only way to check at least one code. So that's it. If you have any questions on this module, please ask them. Кость, а у вас какие-нибудь коды рабочие еще есть вообще с собой? Ладно. Okay, so if you don't have any questions, I'll just again tell you a few words about the last two modules. Не знаю. Okay, so I have... So two modules left. This is about project cost estimation. I have already showed you it, this table in the report, so you just have to fulfill it. That's it. And the last one module should be observed, and you should follow occupational health and safety during the whole time of the competition. That's it. So one more time, to complete the tasks, okay, you may use any information and any documents that we will send you to Google link, to Google Disk. Then tomorrow at 2 o'clock, we'll start checking module number 1, just one module. So tomorrow until 2 p.m., according to Moscow zone, this module should be complete. And consequently, you have 1 day or evening, night, morning, I don't know. You have time until 2 o'clock, until 2 p.m. Moscow time. You have time to just complete or try to perform the modules. So one module, one day maybe for each module. So on Thursday, we'll check module number 1. On Friday, we'll check module number 2. On Saturday, we'll check modules number 3 and 4. Okay. On Sunday, we'll check module number 7, 8, and 9. That's it. Все. Okay, so Dear experts and participants, как выйти с полноэкранного режима? Я не хочу смотреть на Александра Анатольевича Большого. Спасибо. Спасибо, Лех. So, dear all, if you have any questions, so please, you may ask them now, or you may ask them in our chat in Telegram. But still, that is all we wanted to say and to show you for now, because the main idea is that you try to do the modules yourself. So it is okay if something goes wrong, okay? It is not a problem if something isn't working, because if you haven't complete each module, you may just ask your expert, or you may join us and tell us, for example, about your problems. We are training here, and we can also always support, help you. Ну что?
Если вопросов нет, я думаю, можно заканчивать конференцию. И завтра встречаемся.
Точно? А? Okay, so guys, thank you so much for your time, for your attention, for your patience. Don't be afraid, don't be scared about the test project. It's not very difficult, and I really hope that you cope with it and you have fun during this time. So thank you so much. Goodbye.
You tomorrow.
Okay, great. See you then. Bye.
О, кто-то разговаривает.
Bye-bye.
Спасибо вам.
Thank you.
Thank you.
Bye.
Какое эхо. А?
Thank you.
Thank you. You're welcome.
До свидания.
О, чудесно. До свидания.
Bye-bye.